So you have a bunch of things here. So the alpha here, let me just go over a quick overview of the site. The funny thing, Quantopian, like the community, they actually stopped it. So a lot of people are going from Quantopian to QuantConnect. So that's why we have this here. So alpha competition, this is probably not very useful. This is just for like competitions. Yeah, it's probably not. Yeah, it's probably not. You're not going to be here a lot. Market, that's where you buy alpha streams. Like you can buy someone else's. We can't buy it, but you can rent someone else's algorithm, and you'll get like signals and stuff. You probably won't do this either. Probably not important. Data, that's not important either. Like this is where, okay, let's just get that. Okay, okay, so community is pretty important. Oh, that's actually me. Nice, I got 4 upvotes, 19 clones. So the community forum is where you're able to ask questions, and there's a bunch of like posts. Shoot, my face is like on half of these. So you can like read some stuff like threads. We have a bunch of threads, interesting stuff like example algorithms. And if you have a question, you can just create a new discussion, and then you put like seeking help. Well, like just put your bug. I have a bug in my code. Blah 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 blah. And you describe your stuff, and then you attach your algorithm or something, and then hopefully someone will be able to get back to you and tell you what you did wrong or give you some like advice. And within 2 days, the support team, which I'm part of, gets it, and we try to debug your stuff. So I don't really go here too much, but I think it's pretty good if you want to like discuss something. Like maybe if you want to discuss something like about quant finance, like how to deal with fat tail distributions or something like that, you can also go there to ask that. Yeah, let's go to the docs. The documentation, this is all the documentation. So if you want to like look up some stuff. Oops. Like it explains the code, like the code base and stuff. So that's basically just the docs. You can also Google stuff like QuantConnect. You see here, I have like some stuff searched. Just search it up, and then you can try like find the community post, and hopefully someone like answers. You find an answer. It's like Stack Overflow. And now let's go into how to develop. Like, okay, that's just a brief overview of the site. So let's go into how to develop algorithms. So to create an algorithm, you just go here, create new algorithm, and then create algorithm. Okay, so you can notice, okay, so you can do, so this is Python. Hopefully you guys know that this is Python. Okay, so let's go to this line by line. So what is initialize? Initialize is called once when the algorithm is created. It's like the init method, but they make it initialize. So if it was init, you probably have to call super init, but if they do initialize, they can just call initialize. So you don't have to do the super stuff. So set start date is the starting date of the back test. So you can start the back test at 2015, 2018, blah, blah, blah. And then you can also set the end date, set end date. Okay, I have something, so you can over. So this is the end date. So why would you want to be able to change the dates? One thing is that say you want to see how the algorithm does before and after the coronavirus. That could be something you could do. Like so the coronavirus started in like March. Yeah, no, it's 3/1. So we'd set the end date. So maybe like see how it does from like January to like before the corona like really ramps up. And then you can check how it does after the coronavirus. So you can even delete this. When you don't have an end date, it automatically sets the end date to today. So the set end date would like implicitly do 11/17. Set cash is how much cash you have in your portfolio. Not very interesting. Yeah, this is not very. Okay, so so add equity. There's like a family of add methods. So self.add crypto. Oh, sorry about that. So you can do self.add crypto, BTC USD resolution. Oh, so what are these add methods? Well, these add methods, add equity, add crypto, add forex, what they do is they tell the algorithm to start looking at SPY data. So why might this be useful? Like, why don't we only get data that we have to, why do we have to ask for to be able to watch data? Well, if you think about it, there's millions of there's thousands of equities, there's hundreds of cryptos, hundreds of forex. So instead of getting all of that data, we can choose the data we want to look at so that the backtests are faster and less resources are used. However, so if you add equity SPY and you want to try to get QQQ data, you wouldn't be able to get QQQ data. So make sure you want to add stuff here. So let's just add equity SPY. So what this does is it tells us we want to subscribe to SPY data on a minute resolution. What? Okay, there's like multiple resolutions. There's daily resolution. So you get data every day, or we can do hour, like for hourly data, minute for minutely data, second for secondly data. And you can also get tick data, but I wouldn't recommend it because it slows the backtesting down. And you probably don't have the infrastructure to like operate on tick level, tick frequency, because like, I mean, if you're using Python, you probably don't want to deal with tick data. So let's just do resolution to daily. Okay. Okay, so what is on data? Well, based on its name, you'd guess it's every time you get a bar of data. So let's see what this data looks like. So let's do, let's just put the stop point here. And so this is a debugger. So I put a stop point here. Breakpoint, sorry, not a stop point, a breakpoint here. And what breakpoint, okay, it's basically classic debugging. Hopefully you guys know what breakpoints and debugging are. So let's just look at data. It is a slice object, so contains key. So does it contain our SPY? So we can reference it by ticker. True. So if, okay, so let's get the bar of data for SPY. So we get open, high, low, close volume. And that's basically a bar of data. Like candlestick chart. Like it's just one of these. So you got open, high, low, close, and then we can't really put volume on there, but there's also volume. So it's basically a candlestick along with volume data. So why do we have to index it by SPY? Why can't we just do, why doesn't data automatically just the bar itself? Why can't we just do data and get the bar of SPY data? Well, what happens if we have other data like QQQ? So let's just add in QQQ real quick. Okay, let's look at QQQ. So true. Okay, let's look at the QQQ data. And so we have another open, high, low, close bar for QQQ. So you notice that we have both SPY and QQQ in data at the same time. So it's not called every time we get a bar of data for one stock. We get it in a batch. We get a batch of bars of data for all the equities or all of the assets we're subscribed to for data. Okay, so how do we buy and sell these things? Like, I want to buy some SPY. I want to buy some QQQ. So here, so let's just do self dot. So let's just check if we have stuff, if we have holdings or not. So self dot portfolio. So self dot portfolio is our portfolio, and if we invested. So this is part of the QC algorithm. This class has a field called portfolio and has some attributes. Let's see. You can look it up. So QuantConnect portfolio class. Well, okay, so let's find portfolio. So you can see there's you can find a bunch of stuff about the portfolio, how much fees start. So you can get a bunch of data, and invested is one of these fields. Okay. So let's just, so if we aren't invested in anything, self.set holdings, QQQ, self.set holdings, SPY. Oh yeah, set holdings just basically allocates some percentage of your portfolio to the asset. So what does this do here? It allocates half of our portfolio to buying QQQ and half of our portfolio to buying SPY. So let's just see this backtest. And you can see here, okay, so now we are in the backtest. So this is the equity curve of our portfolio. Not very interesting. Now we scroll down here. So the total trades, we have 2 trades because we bought QQQ and we bought SPY, so that adds up to 2 trades. We have a bunch of statistics like compound annual growth return, win rate, net profit, blah blah blah, PSR. It's just a bunch of statistics, random statistics. Okay, yeah, that's okay. So now what? Okay, so that's okay. So you can also do market order. So let's do market order. So what holdings is it's market order, but it automatically calculates how much cash you should allocate to get some portion of your portfolio to like have like the percentage you want. But however, we can do market order QQQ1. Let's just buy 1 share of QQQ. You can see here, we didn't really make much money. The growth is a lot smaller because we only have 1 share. Okay, so that's how you do order. Okay, so let's see how you can get historical data. Okay, so here main.py is where you run the algorithm, and research.py is a notebook, a research notebook where we can do a bunch of cool stuff. So okay, so QB.addEquity SPY. So what that does is it basically allows us to be able to pull SPY data. So let's just run this real quick. And if you're like a researcher, like you're researching if there's any patterns in the price data, you usually want to head into like a one of these notebooks. And these notebooks are like Jupyter notebooks. These are essentially Jupyter notebooks if you're familiar with Jupyter notebooks. Okay, so let's just do QB. Oops, I didn't do dot symbol here. There. So QB.history SPY. Let's do 100 days of data, and we want daily data. So let's just wait. Let's just look at there. Okay, so you can see here that there's this, it's a multi-index. So let's add another, okay, so let's add another thing. So let's add QQQ. SPY and QQQ. I didn't know this thing. Actually, let's look at, okay, so we can see the SPI, but I want to see the QQQ data. Okay, now we get the QQQ data. So okay, so what happens if we just want QQQ or SPI? So we can do that. Oops, that loc. So what we do here is loc. So loc is just indexing. So we index for the SPI. And now we just get the open, high, low, close data frame. And something cool you can do is data close dot unstack. Okay, level equals 0. So what now we have is the closing prices for QQQ and the closing prices for SPI. And so why is this useful? This is nice for portfolio optimization. So if you're like doing some portfolio optimization and you want to maximize the Sharpe of like this price series, you can. This is nice to do it with. Okay, let's go for. Okay, so that's how you do historical data in here. And so you can just pull data and like just research it. Okay, so how can I pull data in here in QuantConnect? So let's just do hist equals self.history. Let's do SPI and QQQ. Let's do like 5 days of data. Resolution.daily for daily data. Actually, while we're waiting for that backtest to, oh, never mind. So let's do hist.loc. Oh shoot. What? Hist.loc SPI. And you can see we get a data frame. It works very similar to how it works in research. Okay, now let me go over what rolling windows are. So rolling windows are like a QuantConnect object. So let's do RW for rolling window. Let's make it a float. And let's have it store like 2 elements. So let's do rolling window.add. Let's add 1. Rolling window.add 2. Let's just cast it to list and look at it. And you can see here, newly added elements are added to the left side. Okay, so let's add another thing. So let's add 3 and list. And you can see here, it only stores the number of elements that we specify here. So as soon as this 3 is added, this oldest element 1 is get kicked out. And so how can we use these rolling windows? Okay. Self.rolling window, let's just equals rolling window. Let's store the slice object. If you remember earlier, when we looked at data, it was a slice object. And let's have 5 points of data. So self.rolling-window.add data. Okay, if self.rolling-window is ready. Is ready just specifies that it is full. So let's just rolling window.is ready. It's just a boolean. It is true. How about let's make a new rolling window. We'll have no elements in here. So let rolling window 1 dot is ready. We can see it's false because this rolling window 1 is newly instantiated and it doesn't have anything. Okay, so data, wait, no, df equals it's like some weird thing. I always just copy it from somewhere else. Here it is. Pandasconverter Getdataframe. What that does is it basically converts a rolling window of data into a data frame. So df. Let's just look at this div. So let's put some random thing here. Oh, it's called rolling window. df.loc. Oops. You can see here it's just the data frame. And so why is this nice? Well, when you call self.history, we ask you for 500 data points, it doesn't really want to give you 500 data points because that's a lot of data, right? So it actually works better to not call self.history most of the time and just use this. Okay, and that's how you convert it. Okay, so let's go over technical indicators. Everyone's favorite. Actually, don't use a lot of technical indicators. So self.SMA. So let's just create a simple moving average equals. How do I create an SMA? Simple moving average. You can actually search stuff up in here. API tree has a few methods. It doesn't have all the methods, but it has a few methods. So it's a nice quick reference. So you can see here. So that's how I fill it out. So symbol period resolution. The selector isn't actually necessary. I don't know why they have it there. So self.sma spy. Let's do 10 and resolution.data. And if self.sma.is ready, let's just plot the value. So how do you plot? You do self.plot. You give it a chart name. So like SMA, let's call it, let's make a series value. And then self.sma.current.value. Let's also, let's just show that like here, let's just make another thing. So value divided by 2, and let's just take this value and divide it by 2, just to show that we can have multiple series. And let's just put this into another chart. Let's just create a new chart, SMA2. Let's just practice this. So why do we want to check if self.SMA is ready? Well, if you have like 5 points of data for your SMA, doesn't make sense. You don't want to use it yet because we want to wait until we have 10 points of data. We want to match simple moving average of 10 points of data, right? So that's why we want to check if it is ready. So we can see here we have an SMA chart according to this. And we created a new chart by specifying SMA2. Now we have SMA2. Taking a while. SMA2. Let's look at SMA. So that's how you can do some plotting. Okay, now what do I want to go over? Okay, so let's just go. Okay, so how else can I like visualize data? So self.log. You can just log something. So or self.debug. Let's just log the log the day. And let's just set this to like 11.1. So these are like 2 methods that allow you to like log stuff. Like, so it's really nice. So self.debug prints it to the console. And then self.log, it puts it to a log. And you can download these logs. Here, let's just download these logs. Now you can see here we have these logs. And that's logging and debugging. Okay, so what happens if you want to specialize SMA? What happens if you want the simple moving average of the high minus low, which is like basically the range? So, okay, so what are even these self.SMA? So QuantConnect SMA method. What is this? Oh, it's a simple moving average. So self.SMA is actually a method that returns a simple moving average object. And creating indicator to self dot automatically updates the data with like the closing values of each bar. Because like you have open, high, low, close volume, uses close to update this SMA. But what happens if we want the SMA of the range? So we take the simple moving average, copy here, let's just look at it. So what are the constructor arguments? So it takes default period. We want a period. So let's create a simple moving average. Simple moving average. Let me just wait here. Let me just undelete that. Okay, let's just start. Okay, self.sma equals simple moving average. Yeah, let's just do 10 again. And let's just okay. And self.sma.update. Oops, sma.update. So what are the two arguments for this update? So self.time, we can actually look here. So let's just look at the members update. You can see all of these things. So where are the methods? Where is update? Right there. So what does it take? It takes a datetime and a decimal. Well, it's actually Python equivalent. So it takes a Python datetime and a float. So let's just get the data. So let's just, okay, so sometimes you can be missing data, right? Why can that happen? Well, data corruption. So say we get our data from AlgoSeq. Wait, yeah, AlgoSeq. Yeah, we do. And what happens if like the server goes out for like an hour, right? And they can't get a bar of data. Then we might be missing a bar of data in our backtesting, right? And so sometimes we can be, or like some data gets corrupted, and so we miss some data. So we always usually want to check if we have data. So data, so let's just do data.bars. Okay, why did I do .bars? Don't worry about it, just copy it. So contains key spy. If not, let's just return. We'll just not do anything. So data spy dot high minus data spy dot low. And okay, so here, while that's loading, let me just go over through something. So this thing called Bootcamp, it actually shows you how to use the platform. You just like, here, let's view it. Then consolidator, and I'll just tell you everything. So this is quite nice to like brush up on the basics. So it's basically just a free course they can take on how to use the platform. And I've said this quite a few times. This is a thing called a strategy library. It's not, you can't actually find it through the tabs. So there's a bunch of strategies in here. To be honest, actually the style's kind of whack. So make sure you try the ones at the bottoms, because these are usually the ones that are updated. Or here, alternatively, you can go to community, find my post, strategy library implementations tabulated for various attributes, blah, blah, blah. So I put in a spreadsheet. And you can see one of the criteria if it was made in 2020. And you can like filter the stuff, like if you want highly mathematical strategies, or you want like traditional finance strategies, these like technical analysis and time series modeling, machine learning, deep learning. So one is if it does that. So which one I went over? This is one of the one I did. is time series analysis, mean reverting strategy, pairs trading, yes, highly mathematical, Minton 2020. So that's how you rate this table. Okay, now you can see that this is the range, and it works. You can see that these values aren't like a lot smaller because the difference between the high and low is like it's not going to be that big. Like the difference between the high and low is around like $5. So like the high of the day might be like 227 for SPY, and the low of the day could be like 222. Okay, so that's how you use technical indicators, and that's how you. Okay, so there's something called a schedule event. So let's go over what a schedule is. So self.schedule, schedule, the on. Okay, so you can just like here, let's just do self.time rules dot week start. Oops, it's date rules. So the first one is some date rule. The second one is some time rule. So time rules. Like let's do after market open. Let's do like SPY after. So you can put QQQ, SPY, or any equity here. If you put SPY there, what it basically tells you is the equity market open. So like NIC open. And SPY's trade on that. 9:30. So if you do 0, this will run every Monday at 9:30. I think it's Monday. But if you do 5, it'd be not every Monday at 9:35. So this always is minutes. If you do -5, then it's every 9:30. No, every 9:25. So you can do negative if you want to do it before the market opens. It's kind of weird, but just deal with it. And then let's specify the manuals. So like let's just do print date. How about let's actually do log date. Log date. Let's just do log date. Yeah. Let's make this all minute. Scheduled events work best with like minute or second data. It doesn't really work too. It actually, I don't think it really. Here, let's do log date and price. So the truth is, when the data is on daily resolution, we get the data at midnight. And the reason that happens is because, say we have, first of all, it allows us to get the true closing values. Like we have to wait until the market closes for us to get the true OHLCV data, right? Because it doesn't make sense to get OHLCV data for a day if the day hasn't completed. And secondly, so we get it at midnight. So these bars, this on data is called during midnight. And secondly, if we trade both crypto and equity, then we can get our equity and crypto data at the same time at midnight. Okay, so let's just do log date and price. Let's just copy this. Def log date and price. It has to be the same because it calls the function. So log date and price self.log self.securities. And what this allows us to do is try to get a security. So I want to get the SPY security, and I want to get the price of the security. Self.log, self.time. Okay, while this is running, self.train, what we can do is just copy this stuff. Let's just copy this. So train, what self.train does is it schedules, it calls the method, and it gives you 30 minutes to have the method run fully. So why is this important? Well, in on data, you only have 10 minutes before like the algorithm just times out. However, if you do self.train, you get 30 minutes for a method. And so training is where you can like put your training data. So let's just go to the log real quick. You can see here logs, price, and the times. Okay. So now let's create a new, let's just call this train model, right? Train model. And so we can like create data. So like you can do self.history, so data equals self.history, SPY, so historical SPY data, around 10 days, resolution.daily. And then we want to get the data frame of the SPY. So it's kind of weird. Like, why do we have to get it? We only have SPY in this data frame. So why do we still need to index it by SPY? Well, by default, it's indexed by multiple things. Indexed by first by the equity, then indexed by the date. So that's why we all, so it doesn't automatically just give you just straight up the data frame of SPY if we only have SPY. We get a data frame with the index of SPY which then has the index of the dates. So we just want the data frame of the SPY. And so we can plug it, we can do like prep data. So data, so x, y equals prep data. And then we can like model equals, store the model, so self.model. So svr x, y. This won't actually work, but I'm just trying to give you the guys the idea. And so this method has 30 minutes to run because we told it that it was training. Okay, so that's the, okay, so let's go over what object store is. Oh, so object store allows you to store data. Here, let me just show you guys something real quick. So self.estimate. Okay, so let's create a okay, no, actually let's just use Lambda. So self.estimate.updated plus equals some like function. And so what this does is every time SMA is updated with a new value, this function is called. And so this basically, so here we're registering a callback function. And this is the function we want to call back to. I'm not sure if I'm using it. So I'm just registering a function to be called whenever this update is called. And so here, when this is called, it will fire off updated and fire off this function. So let's create a function. So let's just create a list. So self.estimate values. So lambda, so we get 2 arguments. We get sender, updated. And let's just update self.estimate vals dot append. Let's just append the updated dot value. So the updated is an indicator. So indicator data point is just basically wrapper class for float. It's not very interesting. So to get the underlying float value, just do dot value. Not very interesting. And sender, this SMA would be the sender because it's sending the stuff to this function here. So sender equals self.estimate. Okay. And let's just store to, okay, let's import pickle. So we import pickle on end of algorithm self. And what is on end of algorithm? Well, the name just gives it away. It calls this function when the algorithm ends. Okay, self.object store. So object store allows us to store stuff. .save. There's a various save methods. So let's just save bytes because pickle stuff is bytes. Let's call it SMA vals. SMA vowels. Let's just store the self.sma vowels. But first, we actually have to dump it. So pickle.dumps just basically converts into bytes. Okay, let's run this. Let's go to research. We can use it anywhere, but so object store is linked between main.py and research. Like, oh, yeah, let me just delete that real quick. Yeah, I deleted that function. Let's just delete that too. So how can I pull this SMA value? So first we typically want to, it's good practice to see if we actually have these SMA values. So if self.objectStore.contains key, what do we call it? We need this string exactly. Where did I put it? Right there. SMA vowels. SMA vowels. And then let's just create the, let's just start, so bytes. So B bytes. I don't know. Let's just call it X. Whatever. So we can bytes pickle.loads qb.object self.object store dot read bytes SMA vowels pickle.loads. And so why do we need to cast it to bytes? I thought it was already in bytes. Well, that's a good question. Oh my God. Saying my own question was a good question. It's like I'm talking to myself. There's someone else in my head. Well, the thing is, oops, we actually have to load. Oops, that in the last spot. Actually, pickle.loads. So what we need to work with is Python by objects. Well, fun fact, the engine is written in C#, right? So the byte array we get when we call self.objectStore.readBytes is a C# byte array. However, we need it to be a Python bytes. So we cast it to Python bytes before we can read it with pickle. Okay. QB, okay, let's just read it out. Okay, so QB dot, so bytes, here, let's just do A equals QB dot object store dot read bytes SMA vowels. Okay, so, and let's just see what's there is. This one's here. What? Try it again. What? SMA vowels. I swear. Oh, I might not get it. Yeah, sometimes. On end of algorithm. Let's see if this is getting called, like, I don't know what's going on. Let's see. Hello? Okay. Zoom algorithm. Let's restart it. Okay. Oh yeah, QuantConnect can be a little confusing to use at sometimes, so be sure to feel free to reach out to me if you need any help. So qb.object. Okay, so a equals qb.object store.read bytes. There we go. Holy moly! And you can see that this is a system.byte. System is some C# class. So let's cast it into bytes. Okay. Oh shoot! And now it's Python bytes. Okay. So let's read it in pickles. So a equals this. Oh shoots! Oh my god! Okay, there. Okay, so let's just do data equals pickle dot. Oh shit! I forgot pickle. Oh yeah, for those of you who don't know, pickle is a built-in Python library that allows you to pickle objects, which is turned into bytes. So data equals pickle dot loads, and you can see. And let's look at data. Let's see here. It's just estimate dollars. Okay, that's how you use object store. It's gonna get a boring. Let's do some creative.
Wait, what is this?
Do you want to play?
Are you still recording? Are you still recording, or?
What?
Are you still recording?
Yeah. I can stop it here.
Oh, sure, okay.
Okay, yeah, I can give have you guys ever used QuantConnect?
No.
Well, hope you guys know now how to use QuantConnect. Is there anything you guys want to learn about in QuantConnect, like how to do something?
Well, I mean, we can probably just Google, right?
Yeah, I'm still probably going to be having to learn a lot more.
Yeah, well, hopefully, you guys know the basics now, because the docs aren't the best, to be honest. Well, all this information is I've used QuantConnect for a while, so but it's kind of hard to learn it because the docs aren't the greatest. Okay. Not much strategies here. I don't really know I don't know what you guys want to do now.
I don't know.
Do you want me to go over one of the algorithms? Well,
I mean, do you ever wonder what people actually trade off of?
Whatever makes money. What do you mean by that? People trade a lot of different things. They'll use anything.
Yeah, I guess.
I mean, are you talking about math or what do you how they create the strategies or?
Yeah.
Well, some people trade technical indicators. I don't really believe in technical indicators, to be honest.
Yeah, I mean, do they actually trade technical indicators and make money?
No, well, some people do, retail traders.
Yeah, okay, but I meant quant trading places. Sometimes I wonder, but it's you can never really know, because why would they tell you?
So I think this is like pretty common. Like, so like a firm gets like some alternative data set, right? And they like use a bunch of statistics to see if like, are you familiar with the Dickey? No, not Dickey. It's called Granger causality test.
No.
It's basically like seeing if one data series.
Granger causality test.
Basically trying to see if one time series causes another. You can see that like here, this like fronts the other one, like when it goes up. See,
Yeah, I'm
this
just
one's
reading the
slightly-
Wikipedia page.
So Granger causality can see if one causes, well, like not really well, cause might not be the right term, but
It's like a correlate.
we just say causality. So they can like use some alternative data to see if like it has like it can tell you something in the future about something. Say, okay, so say you have like foot traffic data for Home Depot, right? Like how many people go in and out Home Depot? Or you like freaking use satellites to scan the freaking cars at Walmart, right? Number of cars.
There's one place that always uses that as an example.
Yeah.
Yeah.
Oh wait, yeah. So you already know that one, so maybe.
Yes.
It's a lot. Okay, something I know. So if you're like working at a bank, they do a lot of like derivatives pricing, right? You know the Black-Scholes? They use some like variant of the Black-Scholes because like you know the Black-Scholes has like a few assumptions that aren't really true, right?
Mm-hmm.
So what you do is just go back to how the equation is derived, like at like before you get to the closed form solution, you have all this stuff to like price option, right? And then there's a bunch of assumptions you have to make, right? However, what you do is you like do code, so you don't have to like modeling interest. I don't know, like modeling interest rates, modeling like different input variables, like for the Black-Scholes. So a lot of like things they like try to use a variant of the Black-Scholes that is more realistic to real data. That's one thing. Like that's pretty big. Like derivatives pricing. So trying to like buy undervalued derivatives and sell overvalued derivatives, right? That's pretty big among like banks. Another thing is arbitrage. I don't know. Well, like arbitrage. You get freaking FPGAs. Shit. Get like nanoseconds, so you get the arbitrage. Oh yeah, apparently like there's like negative latency, right? Because like some hedge fund, I mean some like trading firms, what they do is they infer the rest of, so they get packets, right? They get packets of data. And so they make a decision before all the packets arrive. Right? They make
what do you mean? What packets?
Like you like send data over like the internet or something.
Yes,
over,
are they like intercepting people's packets and looking at how many there are?
Well, like price data, like you get like so say the price for like Apple is updated, right? Mm-hmm. Then you have to get that data for the update, right? And you get it through a stream of packets, right?
Yeah.
And so what some funds are doing is they get like some of the packets, right? Like say like 8 packets represents like a number or something. They get some of the packets, and before they get all the packets, they make a decision and send it. Because they like infer what the rest of the packets will say, right? They get enough packets to see what it is.
Oh, okay.
It's pretty crazy stuff. So they get like it's called, I think it's negative latency. It's like pretty crazy. Some crazy stuff. Another thing is mean reversion. Okay, so the two big classes of strategies are mean reversion and momentum, right? Mean reversion, you buy low, sell high. Then short high, cover low. Momentum, you buy high, sell higher. There's also like fundamental, quantamental, where you like mind factors. Okay, so this is like an example of quantamental. Well, like it's not really. It's more just pure finance. It's not really like any quant stuff. It's just all program. Like bunch of factors. Let me think.
Yeah, I guess the mean
What?
reverting thing makes sense.
Yeah.
And I guess like short-term momentum,
Yeah.
maybe.
Mhm.
Well, like you can measure the degree of mean reversion with like thing called Hurst. Or you can like model as Ornstein and Black. I'm not sure if you like, so this was one of the earlier workshops. This thing?
Oh yeah, I looked at that notebook, the one with the pairs trading and like the mean reverting. You find some combination that mean reverts.
Oh, I have a few pairs trade. I think yeah, this one's the one with like, you know, the Ornstein-Uhlenbeck process, one of the Kahoot questions. Yeah, so this one's also mean reverting, basket of securities.
Wait, what do you mean this one?
What?
Oh wait, sorry. Okay, now okay, yeah.
But, so yeah, this is another mean reversion strategy. So this one's with crypto, right? This one like crypto. This one was GLD and SLE. I don't know why people dislike this. Like, why?
I mean, people always do that.
I have
This
like
is 500 views.
Well, like they're not all like, I don't know. They're like random people too.
Yeah, but like still, I was expecting not that many.
Oh, here, let me show you. So I have it. Okay, so I wrote this, right?
Sure.
And I put my video here.
You're drawing in MS Paint.
What?
You're drawing in MS Paint?
Yeah, Chad MS Paint.
That's interesting. Okay.
I mean, how else would I draw a stochastic process, right? Like,
Yeah, I
I
mean
could
that's
simulate
true. That's true.
it.
Might as well just pull up Paint.
Here, maybe I can post this link in the chat. I'll post it.
So would you suggest QuantConnect mainly for backtesting?
Oh, you can also do live trading. Here, let me show you how to live trade. Go live. It's actually super simple. Alpaca, put some keys. I don't know what my key is.
What the heck is Alpaca?
Oh, it's a broker. It's for free. Here, maybe let me go back. Do you know what? You know?
Oh, I guess I've heard of interactive brokers. Okay.
Yeah, so these are brokers. Well, here, let's just do this next. Wait, well, you have to pay $28 a month, but we actually have like free accounts. So if you have like something that you want to deploy, maybe I don't know, you can hit me up and maybe I could get your algorithm deployed live.
I don't know. Right now, I'm spending like too much time interviewing for stuff.
Oh, really? Like, are you doing quant dev or quant research or quant trading?
I think a lot of what I applied to was quant research.
Oh, really?
Some of it was just like quant trader roles. I mean, I don't know that much finance though.
You
So
still
like, I
interviewing?
applied to like data science roles and ML engineer roles. Yeah.
Dude, I don't know. I've applied in September and I haven't gotten like many more interviews.
Oh.
Wait, like, are you still applying like right now?
Yeah.
Wow. When I see a job posting that's over a month old, I don't even bother. Yeah, so this is CFR. So we have a few like live trading nodes here. So the reason we'd probably use Quant. Okay, so first of all, Quantopian is like the other main like competitor, right?
Mm-hmm.
But here, let's just see. So Quantopian shut down, right? Oh, that's me. I got 36 upvotes. Okay, so and like Quantia. Okay, so Quantopian, Quantax, and QuantConnect. Out of the three, only QuantConnect supports live trading, right? And also, I'm actually paid to like answer these questions. Like, you post a question and post it here. There's paid staff who will answer your questions. Also, they're based in Seattle, which is right next to our university. He actually came to our club one time for a talk.
So I mean, is QuantConnect just trying to be Quantopian basically?
What? No, they actually both started in 2011.
Oh, so are they like?
They were
You're
similar.
saying Quantopian is younger?
Well, Quantopian's dead, so
Oh, okay.
yeah. I don't know. So QuantConnect actually supports live trading, while Quantopian you cannot actually live trade with Quantopian. And also, yeah, we have pretty good relation. Like UW has pretty good, like, I don't know, we're pretty. Like we have pretty good relationships with QuantConnect because like a few people from UW like work there. We actually have a few people working there right now from UW.
I mean, how does QuantConnect actually make money then?
What? Live trading costs money.
Commission or
Here,
Oh,
let's see
okay.
the pricing. So it's free for back testing, but like an organization will cost money. So like most of the stuff you can do for free, but if you want, I don't know. And you can also sponsor it, so it's called Lean. This is GitHub documentation. So it's open source, and you can actually sponsor it, right? Because like all the code is just here, right? You can literally just, you don't even have to use their service. You can run it locally or deploy to a server.
I see.
But you can, if you like it, you can sponsor it. So that's, so sponsorships and, oh, you can also like buy rewards. Like we recently rolled out some rewards. It's like Reddit rewards. I think there's like copy from Reddit here. So I can give him some reward.
Oh, I see. QC credits.
It's basically Reddit Gold.
Yeah.
If you're familiar with the Reddit credits. Okay. Also check this out here. I don't know if you guys want to see this. Oh wait, here maybe. Oh yeah, do you guys want to know about the quantitative analytics project? I don't know if you guys know about it.
Is this the thing with the notebook that you linked like last week or so?
What?
Is this
Yeah,
the
it's
thing
sort
with the notebook from last week, roughly?
Notebook? I don't think it's involved in a notebook. QL. Where did I post it? Okay, so you have to use your YouTube email to see it. Here, I can post it.
Oh yeah, I think I saw this.
Oh, okay. Yeah. It's basically I don't know. Wait, so so here, let me write down. So you said like having a discussion would be nice. Is that what you said? Like,
yeah, I mean,
discussing stuff. Like what? I don't really know what we can discuss. Like, oh yeah, I don't know if you guys are familiar with like the debate between like Nassim Taleb and Cliff Asness. They were debating some like about like fat-tailed risk and if options can mitigate fat-tailed risk. Pretty nerdy discussion. I think QuantConnect actually, like the Twitter, our Twitter like actually responded, and it got retweeted. So and then like a few thousand people joined. So, is that what you're thinking? Like discussing like, right? I don't know. What do you think about? I don't really know what we can discuss.
Yeah.
Well, I'm open to ideas. If you like have an idea or anything, just like email me or Discord me. I'd love to hear it.
Sure.
Like if you haven't. What? I mean, no pressure to like make cat. I mean, I'm running this thing, so it's more on me.
Stat 390, homework 8.
Okay. I can stay around for a little while if you guys want to discuss anything, but like there's nothing more. I don't really have. Hopefully you guys know how to use QuantConnect, like the basics of QuantConnect now.
I'm probably gonna keep on doing boot camp because I'm like partially of the way through it. So
Oh, nice.
I keep on doing that. So alrighty, I'm gonna head out.
Okay, see ya. Have a good day.
All right, adios. Good night.
So would you say that like you would recommend QuantConnect if I wanted to backtest something ever?
Well, what would you? Well, I don't really know what else you'd use. Wait, what else would you use? What are you thinking?
I don't know. I vaguely remember like Zipline, but is that the thing connected to Quantopian?
Yeah, this Quantopian's open source algorithmic trading, but it's pain in the ass to use. QuantConnect is really nice because it's all free. It's 100% free.
Yeah, that seems really cool.
And if you like sign up with your UW account, you actually get some free credits.
Oh, okay. I might sign up then.
And we have a good relationship with them. So that's probably like this one. I mean, here, I can show you something. I actually backtest this an algorithm, like not on QuantConnect.
I think I saw this.
You actually saw this, really? That shit.
Yeah, I vaguely remember seeing this notebook.
I don't think I ever showed this right
now. I think it was linked from like the project thing from last week.
Oh, yeah, truth. Yeah, true. Yeah, I created like a mini backtester here. It looks very similar to like friggin' QuantConnect. Well, I've used QuantConnect, so pretty familiar with it, so I just like recreate it slightly. It's not the best. But, well, like, I just wanted to put everything in this notebook. But, like, do you see this? Like, this is kind of ugly. Like, and there's a lot of stuff that, like, you have to program everything yourself. And, like, and also I can help you. Like, I can help anyone who needs help with QuantConnect, right? Because, like, I'm pretty familiar with it.
That's cool.
Yeah, so like if anyone needs help with it, like they can just ask me. I'm gonna stop recording.